Our guest this week is Kurt Kelty, who is Vice President of Batteries at General Motors. Kelty has been in the battery industry since 1991 and was an early employee of Tesla, where he worked on the battery pack of the Tesla Roadster electric vehicle. In March 2020, GM unveiled its Ultium battery platform as part of CEO Mary Barra's all-out push towards electric vehicles. It aims to lower battery costs by using the same battery components for all electric vehicles. As part of a joint venture with Korean battery producer LG Energy Solution, the two companies have already built 2 battery plants in the US. In this exclusive interview, Kelty talked about the benefits of the Ultium platform, the progress at the Ultium battery plants, future battery chemistries, and battery raw materials. Kurt, thank you so much for joining me today. It's fantastic to have you on. Just to start, you've been in the battery industry since 1991, I think, right? Which is when the lithium-ion battery was commercialized?
Yes.
What has surprised you most looking back over the years in the development of the lithium-ion battery?
Well, as you say, I've been in this for a long time. When I joined the business, we were still selling NiCad batteries when I joined Panasonic back in 1991. I think the big surprise is when I got into the battery business, if I went to a cocktail party and said I was in the battery business, I was kind of delegated to the exterior part of the party. Now, if you say you're in the battery business, you're the center of attention. Things have changed over the years. I never thought lithium-ion battery folks would suddenly be popular, but that has occurred over the years.
Interesting. And talking about General Motors, I'd love to chat about the Ultium battery platform because describe that as being at the heart of the company's all-electric strategy, which will power everything from mass market to high-performance vehicles. I wonder if you could describe the benefits of this platform that GM's come up with.
Yeah, so as you can imagine, it's like a skateboard type of design, the Ultium platform, and so it's common motor, common controllers, the common battery module, battery cell. So it's a lot of common components that we're able to assemble together and put in in different vehicles. And so it provides us a great deal of flexibility where we can, whether it's we can make using the same components, we can make a Lyric, or we can make if you can go down the list of all the Blazer or the Hummer, we can do all these different vehicles with the same set of components. And it's a matter of rearranging them or adding more modules, adding extra motors. And it gives us flexibility to come out with a lot of models without having to do a great deal of new development work. It also gives us flexibility where we can make up a new vehicle very quickly. For example, the Blazer, we can go from front wheel drive to a rear wheel drive very quickly. It's very hard to do that in ICE components. So flexibility, it allows us to ramp up quickly. If you can imagine a lot of the components being very similar, if one vehicle is selling more than another, we can steer our production over to that other vehicle. So the flexibility and enabling us to ramp quickly is really what it provides.
And does that result in significant cost reductions then?
Absolutely, because we're able to drive down development costs, and we can get these economies of scale because we've got this much larger volume that we can attribute to multiple programs. So it does provide a great deal of cost reduction opportunities.
And is that because the cells can be stacked either vertically or horizontally, right, in terms of the different models?
Well, no, it's not so much the cells being stacked. I mean, remember the cell and the module are one part of the Ultium platform, but we can stack the modules on top of each other. So not necessarily. So we're going to still go the same way with our pouch cells, and then we could stack modules on top of each other, and we do that. For example, the Hummer or the Silverado, that's basically taking a Lyric pack. Where you may have, let's say, 12 modules or 14 modules, and you basically put another pack on top of it. For the Hummer. So you end up with 20 or 24 modules in the Hummer. But the basic building block, that module from the Ultium platform is the same. And so we can really drive that economies of scale there because it's the same thing. We're just putting more of those modules in the vehicles.
I was interested to ask, we've seen the Chinese sort of eliminate the module and do cell to pack or cell to vehicle. Is GM also looking at that kind of approach?
So we keep a close eye on our competitors, and so we know very well what they're doing on cell to pack, and we've got some efforts underway internally, without going into a whole lot of detail, where we're figuring out what is the most efficient packaging arrangement. And it depends on the cell form factor that we're using, the cell chemistry. So we may go cell to pack with certain chemistries. For example, LFP, a prismatic LFP would be much more conducive to that because it's a prismatic cell, so you can stack it much easier. The energy is lower; it's considered safer, so you can position them closer together. It depends on the cell chemistry, the cell form factor. So we're looking at multiple options for that.
And in terms of the chemistry, Ultium uses the nickel, cobalt, manganese, aluminium, NCMA. What's the advantage of that? Because I remember GM saying it reduces cobalt by some 70% compared to, I think, previous versions. What's the advantage of that chemistry?
Yeah, so that's what we consider high nickel chemistry, and there's different forms of that cathode that gives you a similar kind of energy density. You can go NMC, you can go NCA. The real driver is the nickel. How much nickel do you have in there? That's going to drive the energy density of the cell. That's one of the big drivers. So we've opted for NCMA. It's very high nickel content, and that gives us the highest energy that we can get from those cells, and that's what we need for our vehicles that are on the road right now. These high energy nickel cells in the Ultium platform are really what enable the great driving range and the great performance we get from the vehicles.
So do you think for US consumers, it's going to be a market of high nickel cells or mid nickel cells?
I think the market's going to be split. There are vehicles that require the high energy density, and some of these you may put silicon in also to get an even extended range further. You can imagine with a high nickel now, and then you put silicon in there, and you get another 20% increase in your energy density. So you can do that, but there's also markets at the lower end of the range for energy density, where it may be appropriate when you have a lot of space, but you've got to really drive down cost. You may use a different chemistry. So there's a market really from LFP to mid nickel to high nickel to silicon. There's a market in the US for it. It's just a matter how big it is.
And talking about LFP, lithium iron phosphate, I mean, in China, we've seen that share, I think, go up to 70% now in the Chinese market. I mean, there were reports that GM's talking to CATL or others on LFP. What's the sort of LFP strategy then?
Yeah, let's go back a little bit on LFP. So LFP was first invented in North America, and this is a typical case where it's invented in North America and then it's commercialized overseas in Asia. And in this case, the energy density was not too high with LFP, and so U.S. companies were not super interested in it because they were looking at high performance vehicles initially. And the Chinese really got into it because they were just starting to get in the battery business about 20 years ago. And when you're getting into the business, something new like this, what you want to start with is something safe. And LFP was a very safe, easy chemistry to make. It's if you're going to make any chemistry out there, you're starting from the beginning. Start with something simple. And LFP was that simple way they got into the business. And so they started making LFP cells for years, and they did a great job. And they were pretty much ignored by the Western world because nobody wanted these LFP cells, but China did, and they built it, and they increased the energy density over the years. They drove down the cost, and they got really good at it. And the Chinese government protected them also because they put in place some safety requirements that were very difficult for nickel cells to meet. So they were protecting their own market. Because you couldn't come into the market with nickel cells because they weren't allowed to be sold for safety reasons. So which was unreasonable. But this is what the Chinese government does very good. They're bringing up their industry, and now they're very strong. The Chinese companies right now, they're leaders with LFP without doubt. And now the question is, okay, what are we going to do in the States? Are we going to adopt LFP? Because LFP has the advantage; it is low cost. It has the drawback of being lower energy density, but it's low cost. And so if you think about where it's going to go, there is a place in the U.S. for that. Our market will benefit from from these low cost cells. And so to me, it's not a matter of if LFP is coming; it's just a matter of when and how much quantity. And so there's multiple companies now looking at localizing LFP production in the U.S. and it makes a lot of sense. Right now, there is not scale of LFP. I don't even think there's any LFP production right now. There are multiple factories that are under construction right now. So there will be LFP in the next couple of years that'll be manufactured in the U.S. and that'll be really exciting because that'll drive down prices more and it'll lead to more sales of EVs.
Interesting. So just talking about battery manufacturing, obviously Ultium Cells joint venture with LG Energy Solution. Your second plant started earlier this year and third's in construction. What are the challenges of scaling up these plants in the US, with I guess, slightly higher cost labor force in the US, the automation required? Could you talk a bit about the challenges of ramping up production?
Yeah, I mean, I think you could always you could also start with like the challenges of making battery cells in general. And I think if you look to the case of Northvolt, and not to say anything bad about Northvolt, but they started over 10 years ago and they're struggling right now. And it because making battery cells is really hard. You can look at Tesla. Tesla's making 4680 cells and they're struggling right now. It's questionable how much longer they're going to do it. What I think is what we did, which was really smart, I think, in the early days, is that we paired up with LG and we made a joint venture with them because LG knows how to make cells. I mean, they're world leaders in making cells. So we linked up with them. We made a joint venture. They brought in their expertise. We brought in our expertise in manufacturing. And together we've made just tremendous strides in building up our cells. So we started on our plant in Ohio. We're nearly at 100 million cells at this point of production. We've taken that learnings, brought it over to our Tennessee facility. We ramped up production there. We've already hit our end of year targets on yield. Our OEE, our operating efficiency, is above target. So we're doing really well. And I have to give credit to both teams, the LG and the GM team, for being very successful. I mean, this has been, 2-3 years since we started production, and we're hitting it out of the park right now. So yeah, we're doing quite well on the production side. I feel really good about where we are.
And can you give any sense of what the yield is? I mean, I saw reports saying Tennessee is achieving 90% yield. I don't know if that's accurate. Could you give us an idea?
What I can say is that I just got back from a trip to China and at multiple manufacturers there. I asked what their yield was, and we were better than the yield at each one of those factories. So I was feeling really good when I heard that.
Well, interesting. And in terms of the challenges, are they at more the cell level or the module assembly, pack assembly? Where's the sort of critical challenges?
Yeah, so in the early days, there were cell challenges, but the biggest thing that we were struggling with modules. We had all sorts of module issues, and this is before I joined up with GM. There were all sorts of module issues that were driving the company crazy at that point, but those have been resolved now, and so the production issues we are behind us. Last year, I know there were a lot of production issues at GM, but this year, but both on the module and the vehicles, we're really doing much better this year.
In terms of raw material supply, I mean, GM's been one of the most proactive in signing agreements for lithium, investing in Lithium Americas, for graphite in Canada, other minerals. How has this strategy helped? Does it help you lower costs? What's the advantage of going out and securing this supply?
Yeah, so I mean, the big thing with investing in the raw material in the supply chain is to drive down costs. That's what we're looking for. So we're driving down costs. We're reducing our risk. We're making sure that we have material available to us in the future. It also we also learn tremendously from this. It reduces our development costs in the long run. So there's a tremendous amount of advantages to investing in that supply chain. The other thing that we're doing is we're really focusing on the supply chain in North America because we're really trying to localize as much of production as possible. And that localization is really key for us. What that does by whether it's a cathode material, anode material, it doesn't really matter. If you're bringing that locally, you're able to reduce costs that much further because you not only have the logistics costs that you're reducing, but the other thing to keep in mind is that when you ship product, like let's say you're buying a cathode material or anode material, and it's coming over from Asia, it's on the water for roughly 5 weeks. It's sitting out there. Now, there's a couple of hidden costs there. There's the interest rate cost of that money. You got tens of millions of dollars on the ocean at any given time. So that's a real issue. The other issue you have is that product is getting stale while moving. Not getting stale in the sense of a shelf life, but let's say you want to make a change on your cells. You want to tweak it ever so slightly. You can't do it because you got product coming in still from when you made it 5 weeks ago. So you got that issue. Then the other issue you've got is, I mean, you remember 2 or 3 years ago, our supply chain problems in the U.S. We couldn't get anything. I mean, that 5 weeks was 5 months, and without that material, you can't make a cell. So a lot of the investing has also been focused on localizing, so bringing it to North America because it just those benefits that I rattled off earlier with the cost. Being the leader, there's a lot of other hidden costs that go with a supply chain that's overseas.
And how hard is it for you to meet the requirements of the Inflation Reduction Act, given that no Chinese companies can be involved, they have foreign entity of concern provisions? Is it hard to meet those requirements?
For some of the materials, it's harder than others. The cathode material, bringing that local, I think has been easier for nickel, for example. It's faster than it has been for LFP. Bringing LFP local is a little bit more challenging. But each one of these, we have a whole team that we just go down the list and look at our bill of materials and we say, okay, how can we get this localized? How can we do it on this one? So it's a big team effort on trying to get there, but it's all doable. There's nothing that we can't fundamentally source in North America. We should be able to get it all here. There's going to be cheaper places. Morocco is one country that many companies are taking advantage of our free trade agreement with them. But fundamentally, we should eventually be able to get this in North America.
But what's that do to costs? I mean, where do you think costs can be competitive in North America? Because that threatens EV adoption, right? If costs are too high.
Absolutely, it affects. I mean, we've got to do this with cost reduction in mind. So we can't just pull. We've got to think creatively. Like for example, getting rid of graphite that comes from China. Now it's really cheap, the graphite out of China. So how are we going to deal with that? Well, we can buy it here locally, and it at a higher cost. What about if we change the mixture between artificial graphite and natural graphite? What if we put some silicon in there, some domestic silicon, increase the energy density that way? So we've got to think creatively. We can't just take the same material like graphite and just try and put it in North America and expect it to be the same cost. But we also have to, when we are looking at costs, we have to include all the hidden costs that I was talking about earlier. We can't, it's not just dollars per kilogram, it's dollars per kilogram. And what about the logistics costs? What about the timing delays coming overseas? What about emissions? I mean, that's another big one because emissions we are going to put dollar amount to in the future. How much CO2 emissions when they're mining that graphite? We got to put a dollar figure. We can't say that's free, that damage to the environment. So we got to look at the whole cost there when doing that analysis.
Yeah, I was going to ask. I mean, what kind of measures do you have in place to promote ethical or sustainable sourcing?
Yeah, so we've got our code of conduct for the supply chain that we follow, and I mean, really, in terms of human rights, it's cobalt. That's the big one, and that comes from Congo. And we're reducing the amount of cobalt in our cells right now. It's single-digit percent going to smaller percent in the cathode. That's really the only one that's has human rights issues associated with it. But we make sure that we're buying clean cobalt and it's all certified, so there's no violations there. But ultimately, we want to get rid of it. That's the idea. But we do have a supplier code of conduct that we force all of our suppliers to work with us on. The other thing we do is just internally, we try to do the right thing. For example, recycling. So any kind of scrap that we have at the Ultium factories, it's completely recycled. We work with a company called Redwood on that, and they take that and they recycle it for us. The other thing is any battery packs that come back from the market, any battery pack, 100% of them that have come back have been sent out for recycling. So we try to reuse that material. And I want to emphasize that battery materials, when we say recycled, it's not downcycled. It's reused in the same form, in the same ultimate end product. It goes back into a battery. We're not taking the cobalt and then downcycling it as a paint or something like that. We're putting it right back into batteries, and that's so we're all the nickel, the cobalt, the aluminum, the copper, all of that goes right back into batteries.
And how do you see recycling? Because obviously, as the yield improves, obviously there's going to be less and less scrap waste. I mean, do you see it eventually getting less and less then?
Well, so the because the yield is so high already to begin with, there's not a whole lot of scrap that comes out of the factories. The scrap that we really want to collect is at the end of life of vehicles, and we're not going to see that for a while. I mean, realistically, I mean, we're building up those businesses right now, but it's years until they're really going to have a significant impact. So, I mean, let's say 10 years from now, 20 years from now, then we're starting to talk about some real volume coming back from the marketplace and then reusing that. And we're developing our full life cycle to have it a closed loop life cycle for recycled materials. Right now, the way the materials go is they go to a recycling company, then they end up being sent back to Asia for use in new cathode materials, and then it comes back to us in cells. In the future, will all be done domestically. So all within the US, we'll take those end-of-life batteries, recycle them, reuse that material in a cathode and in the US, and then put it back into a cell in a vehicle in the US.
Got it. That's interesting. And in terms of when you look at the raw material markets, obviously they're struggling with low prices at the moment. Does this concern you about, these prices won't incentivize new investment in what you want, right? Localized supply or North American supply. Are you concerned about that impact?
Yes and no, in the sense that right now the prices seem to be stabilizing. A year and a half ago, they were crazy high, and they've now become much more closer to historical prices. So this is really good for the industry. Low raw material prices mean low battery pack prices, which means low EV prices, and so that's going to help sales that much more. So yeah, we're really we want the price to stay low. What we don't want to see is a dramatic price drop, and then, as you say, people will stop investing in it. But the way it is right now, there's even lithium prices the way they are today. We're talking to lithium startup companies that are just roaring to get going, even at today's prices. So if they drop significantly more, then we got more of a challenge. So we do want low prices, but to only a certain point.
Got it. And in terms of battery production, you mentioned earlier about being competitive, being imaginative to be competitive with China. What other things are you looking at, sort of dry electrode, manufacturing, coating? Are there other things that could lower the cost and improve the efficiency?
Yeah, so we've got this is one of the things that was really surprising to me when I joined up with GM. I was originally, the deal was when I came over here that I would sign up a team in the Bay Area, open some labs up there and do some R&D there in parallel with what we're doing here. But when I came out here, I was really pleasantly surprised. We've got just state-of-the-art labs in our R&D facility. That has been built up over the years. It's just amazing the amount of equipment we have and the capability of the engineers here. And likewise, we've also got what we call the Wallace Center here, where we make our initial prototype battery cells. These are large format cells, so we can make 50, 100 amp hour cells here. And we've got these tremendous capabilities. So with the capabilities and the team in place, we're able to look at all sorts of different technologies that are coming down the pipeline. And we spend a lot of time start working with the startups. And we're really fortunate having the name of GM behind us, because everybody wants to talk to us. They think GM, well, big volume, so we should talk to them. And so we get everybody coming to talk to us, and it's great. So then we get first look at these technologies. We can analyze and we can ask for samples. We can, if it's a material company, we can make coin cells and multi-layer pouch cells, then scale it up to large format cells. And then when we get good results, we can then go to our cell manufacturing partners and say, look, we've already developed it to this point. Let's take it to the next step of production. So it's really been quite impressive to see what we've got here, and we're continuing to build on that at GM.
And what do you see in terms of, I mean, your background? You used to work for a silicon anode company. Benchmark, we're tracking that, and we've seen, I think we forecast over 500 gigawatt hours capacity for silicon anode battery materials will come online this year. So this is really commercializing now, right?
Yeah. No, definitely. I mean, if you look at the technologies that are coming out, I mean, solid state, everybody always talks solid state or lithium metal or semi-solid state. And those are all interesting technologies that are still in the labs. They're not ready for prime time. And I want to contrast that with silicon. Silicon is out there. There's samples made, contracts being written up for this. As you say, the volume production is starting. And so that's more of a shorter term. So silicon is going to come out next several years, and then where solid state or lithium metal, where they end up, that's going to be more in the future. So we've got an advantage though in that. So we've got these silicon companies. We're testing their materials. Previously coming from Sila, we were one of the leaders, and Sila still is in the silicon space. But I only had that vision of what Sila's material was, and it's great to be on the other end. It's like, oh, I can now see what all the competitors are doing now. So I've really enjoyed that. But silicon is here, and we will. The advantages there are increased energy density, and the fast charge time is improved quite a bit as well. And then once we get, lithium metal has some advantages, but boy, it has some real safety concerns that I think we'd all recognize in the industry. And solid state looks really promising, but it's just not ready quite yet. And I know there are companies have been talking about this. Heck, I've been hearing about it for over 15 years or so. I think Toyota's first announcement was probably in 2007 or so, when they first announced that they were going to come to market with solid state batteries. And it's been a while. And I think it's still got a few more years left in front of it before we actually see that in the market.
So could we see that before the end of the decade?
Oh, that's a good question. We're going to look into it and analyze all the different companies out there. You'll definitely see silicon before the end of the decade. Solid state, I've talked to a lot of folks in the industry, and the consensus I'm getting is quite a bit later than that. But if the company can get over some of these technical hurdles and the cost challenges, then it might be earlier. Now, semi-solid state will be earlier. We're seeing Toyota's going to come out, Samsung's going to come out with it. So there are going to be some interesting semi-solid state products that'll hit the market in the next several years.
So you mentioned range before, obviously important in the US market, but charging time is also critical. How do you see that coming down? Where do you think we can get to in terms of charging time?
Yeah, so charging time is interesting. That the amount of work that's going into it, including here at GM, we're trying to bring it down. The average time that it takes to fill up at a gas station is roughly 8 minutes. So I think we all know what the target needs to be. Right now, most of the GM vehicles are over. They're about 30 to 40 minutes, somewhere in that range. So it still takes, and it depends on what percent you're starting with and what percent you're ending with it. And there's all sorts of different ways to measure it. It also depends on the charger. If you can find the power supply that gets you 350 kilowatts, then you can charge quite a bit faster. The other way to deal with this is get a really long run time, and we've dealt with that. Like the Equinox that is on the market right now is the lowest price vehicle that gets over 300-mile range. And so if you get a long range, then you don't need that quick charging as much. Likewise, we've got our Silverado truck that gets close to 450-mile range. So it's really long mileage. So you can deal with it in two different ways. And we're approaching it both ways. We're trying to increase energy density. We're reducing charge time. So we're doing all that in parallel.
I think you said a few years ago that lithium-ion may be reaching its maximum capacity or theoretical maximum. Do you still believe that, or is there still some way to go?
Well, we've certainly seen with silicon, you can get another 20% energy density from it. There are still opportunities by improving the anode with silicon. Cathode improvements continue to be made, but it's not on the trajectory that it was when I first joined the industry, when it was just back. It used to be that batteries every 10 years you would get a doubling in energy density. That was kind of the rule of thumb. You did that with NiCad. We did that with nickel metal hydride. We did that with lithium ion for the first probably 15 years or so. And then after that, it started to taper off. And so it's still in that tapering off. It's still increasing, but it's tapering off. So we're not getting those great increases like we used to.
Interesting. And what do you think about chemistries like LMFP, boosting the range of LFP?
Yeah, no, I was actually talking to our team about LMFP last night, and there is interesting possibility there. You can get higher energy density both on volumetric and gravimetric with LMFP, and China is kind of leading the way with that again. But then the question is the price. Can you get the price to drop lower than LFP? Or is the difference that if you get 20% more energy density, can you keep the cost increase less than 20%?
Interesting. And just talking a bit about your history, obviously you came from Tesla, you were involved very early on in Tesla. What did you bring from Tesla to GM in terms of thinking about the battery or ways of doing things?
Yeah, well, that's a good question. What did I bring here? Well, I think one of the biggest differences here at GM and at Tesla, where I came from, is we made decisions very quickly. It was very much top down. So if Elon didn't make the decision, then we were all trained to make decisions in place of him, and so we'd be very quick with decisions. At GM, it's much more of a consensus based company, and so you got to kind of bring the team along with you. And as one of the benefits of that, the drawback is it takes longer to make a decision, but one of the benefits is once that decision's made, it's much faster to implement because everyone's already on board. So that's something. I go through a list of things like hiring people. I'm trying to hire somebody right now at Tesla. We had a hiring machine. We were just hiring all the time. GM's not quite as accustomed to that, hiring people over and over again because they've got a stable workforce. But there are things like that I can bring. I'm very much a goal focused person. I work on quarterly goals, and I force all our teams to have a list of their goals for each quarter. I spend quite a bit of time in the beginning going over those goals and making sure that we're aligned on what it is, and much less time reviewing the results. But the big thing is to get aligned right in the beginning. And GM is more of a yearly goal company. And I don't think as metric driven as I'd like to be. So things like that a little different way of working that I'm used to.
Got it. And Kurt, what are you? How concerned are you about reports of EV growth slowing down? Well, it is slowing down, right? We see in the data. Does that keep you up at night? That we've had tremendous growth, but it does seem to be slowing down at the moment. And what needs to happen to spur sales again?
Well, the growth is. There's so much talk about the growth being not very good. Keep in mind, we're still growing. Last quarter, Q2, we grew 11%, the whole market. That's not bad. And that was 22% higher than Q1. So, we're still getting some really good growth. And GM in particular, we're going, the only EV we had in the market about 2.5 years ago was the Bolt. And now by the end of the year, we're going to have over a dozen models of EVs. It's incredible how many different vehicles we've got on the road right now. So our growth, we grew 40% in Q2 versus the previous year. So we're getting really good growth at GM. Now, would we like more? Absolutely. We want this thing to pick up. This is why I'm here. To me, it's all about how can we sell more EVs, and we're doing really well right now, but we've got to do better. The whole industry. Now, how do we do better? We got to continue to make great cars. That's first thing. And great cars is longer driving range, lower cost, faster charge. Those are things we got to get. But to me, the biggest thing that I've noticed since coming out here and driving GM vehicles, the car is excellent. The charging infrastructure is not excellent. It's kind of an understatement. I came from the supercharging network, which was fabulous. It's a seamless charging network, and the rest of the world needs to improve the charging experience. It's much better than it was a year ago, from what I understand, and that's much better than the year before. But we got a lot of improvement that we can still make to really make it better experience for the consumer.
And what about things like vehicle to grid? Are you looking at that? How important is that for consumers? I mean, it's important for the grid, right? But is that a selling point as well?
Vehicle to grid is something that definitely. I mean, right now in the short term, we're going more vehicle to home. And so we've got several of our vehicles are equipped so that you can hook up your vehicle to be a backup to your home. But the vehicle to grid is where we're going to be going. And what we need first is we need better cycle life out of the battery cells. Right now, you get roughly 1,000 cycles, 1,200 cycles, something like that. And it gets you a lifetime of 200,000 miles, 250,000 miles in a vehicle. But if you started to cycle that every day with a vehicle to grid application, then suddenly your battery is going to die before your car is. So we've got to increase the cycle life on batteries first before we can enable that. And we've got eyesight in the next several years on batteries that will cycle long enough to support vehicle to grid. So that is coming down the pipeline. It'll definitely be before the end of the decade that we'll have vehicles out there with that capability.
Interesting. And just to say, sort of last question about looking back over your career, I'd be interested to hear why was it that the US and Europe sort of lost out on battery, the battery revolution, and China did so well. I mean, you mentioned the regulation they put in place, right, which was quite protectionist in some ways. But yeah, what's your thoughts?
Yeah, I think the real reason from the beginning was that the market was over in Asia. So the market remember when the battery industry was starting in China and in Korea, it was because all the electronics were made there. And so you're right. Even though the invention was made in North America, the actual the applications, whether it was cell phones, laptops, power tools, those are all made over in Asia. And there's so much importance in that communication between the customer and the battery cell supplier. And a lot of these companies are vertically integrated, like Panasonic made all those components. They made laptops, cell phones, power tools, Samsung, LG, Sanyo, same thing. They all were doing this, and they could actually lose money because they were supporting their other businesses. So because the markets were over in Asia, they ended up the battery cells were made there, and the reason electronics were made there is because they're good at manufacturing. So that's why it started there, and EVs have come around there more in the last decade. Remember, Tesla got started when I was there. We were buying laptop computer cells. That's what they were, 18650. So it wasn't a specialized EV cell. And just over the last decade, things have changed. So what we're going to see over the next 5 years is tremendous growth in North America, especially the US, in battery cell production. So, and part of that is because we brought the customer back. We got the EVs that are made in the US. The cells are going to be made in the US going forward. So it's going to be really, the balancing is really going to be rectified over the next few years.
Got it. Well, thank you so much, Kurt. It's been fascinating to talk to you. Thanks for taking the time.
Thank you.